Hey everyone, so here is day 2 of integration by parts, which is basically the reverse of the product rule. So again, here is our function, and this is all based on the product rule. And typically this is not 100% of the time. U equals our easier function. The function whose derivative will become simpler. That's a not 100%. This is not necessarily that easy of a topic. All right, so I want you to pause the video, do this one on your own. This is just a rehashing about what we did the other day. All right, so u equals and then dv equals. U is my easier function, which in this case is x. dv is everything else. So e to the 3x dx. So then I'm going to find du. du is 1 dx. To find v, I'm going to do the integral. So that's 1/3 e to the 3x. So now I'm going to plug into my formula, which is uv minus, my brain stopped working, v du. That's it. All right, so it's x over 3 e to the 3x minus the integral of 1/3 e to the 3x dx. So I always write it the same. So in my head, I multiply those. That's the first part, uv, and then I multiply those. So that's kind of how I remember it. So I don't really have the formula that memorized. All right, so now I have to find the antiderivative of the part on the right. So the first part stays the same, minus the antiderivative of e to the 3x. I divide by 3, so that 1/3 becomes 9, 1 over 9. So this is not, this is as easy as it really gets, right? We can't get much easier. So now we're going to do a problem that's harder. So I have, again, the same idea. U is my easier function. So I'm going to make that my x squared. dv is sine. du, the derivative is 2x. v is the antiderivative, negative cosine x. So we get negative x squared cosine x minus the integral. That actually becomes plus because that negative cosine. 2x cosine x dx. Forgot my dx, that's a plus. But now we can't do this. So we have to do this again. So same process. My u this time is 2x. Now you can put the u on the outside, make your u x. It doesn't actually matter. Since I have it like this. Now it's important to stay consistent. du, derivative of 2x is 2. Antiderivative of cosine is sine. So now I'm going to rewrite the first part. Negative x squared cosine x plus, multiply my diagonal, 2x sine x minus the integral of 2 sine x dx. Now I'm down to the point where I know how to find the antiderivative of this. So negative x squared cosine x plus 2x sine x plus 2 cosine x, and then don't forget your plus c. So it's a little bit of work when you have more than one, but you want to get, basically what happens is we need to get that x squared down. If that was x cubed, you would end up doing it 3 times. So you have to just keep going until that x, you take the derivative of the x is down to a 1. All right, so pause the video. Try this one on your own. It's the same idea. So just like before, u equals x squared. dv equals e to the 5x. du is 2x. v is 1/5 e to the 5x. This gets complicated with the constants. Like, it's really easy to make a silly mistake due to those constants. All right, so when I multiply these together, I'm going to make that a 2/5 on the outside. 2/5 x e to the 5x dx. All right. Do you have to do it that way? No, I just like doing it like that. All right, so now my u is x. My dv is e to the 5x again. du is 1. V is 1/5 e to the 5x. All right, so this, I rewrite this. I don't like leave stuff blank because I will mess things up. So now 2/5 times, and I always put a bracket there because we're going to have to distribute. So I multiply my uv, so that's x over 5 e to the 5x minus the integral of 1/5 e to the 5x dx. So this becomes 1/25 e to the 5x plus c. But now I have to distribute. So I have to distribute the 2/5 into everything. So my final answer is x squared over 5 e to the 5x minus 2x over 25 e to the 5x plus 2 over 125 e to the 5x plus, nope, minus minus 2 over 5c. Right. So you do have to distribute that 2/5 over to everything. If you don't, you can leave the 2 over 5 within the problem and you will, you should get the same answer. Your C might be off. It really depends. It's not something I would really focus on. All right, so now this one is the hard one. All right, so this is gonna take a couple steps. Now, if we take the derivative of either of these, will you ever get down to 1 like we did with x squared? No, e to the x is just e to the x. Sine is just sine. So it actually doesn't matter which way you do this. We're going to do this in multiple steps. The key for these, when you have something where it's not going to cancel out, you need to be consistent. Number one most important part of this problem is consistency. So I'm going to let my u equal sine x and my dv equal e to the x. I don't really have a great reason for that. I guess because the antiderivative sign is negative cosine, there's really no rhyme or reason which way you do it. It's just whatever you want. So du equals cosine x dx, v equals e to the x. All right, so now this one I'm going to do slightly different. I'm actually going to rewrite the original problem. So I get e to the x sine x minus the integral of e to the x cosine x dx. All right, so that's my first step. All right, we did this one. Now we're going to do it again. So when we pick our u, the most important thing here is to be consistent. In the first half of the problem, my u was sine. It was the trig function. So I have to do that here also. My dv was my e, so here it also has to be e. That's really, really, really important. So the derivative of cosine is negative sine. Antiderivative is e to the x. All right, so we have this to go away. So I have more room. Okay, so the integral of e to the x sine x dx equals e to the x sine x minus bracket e to the x cosine x minus the integral of e to the x negative sign. So this becomes a plus because of this negative here. Sine x, I'm running out of space, dx. I shouldn't have put this here. Okay. So, again, I'm going to rewrite this again. E to the x sine x dx equals e to the x sine x. And now I'm going to distribute the negative through. I'm going to distribute through this negative. So minus e to the x cosine x minus the integral of e to the x sine x dx. All right, so now look at this problem and tell me what you notice. What I hope you see is that we have the integral of e to the x sine x over here and the negative integral e to the x sine x over here. So what we're going to do is we're going to add the integral to both sides. Treat that like it's a variable. Sine x dx. That cancels. So I end up getting e to the x sine x minus e to the x cosine x equals 2 times the integral e to the x sine x dx. So then the last step is to just divide by 2. We want to get the integral by itself, divide by 2 on both sides. So the integral, the problem we were asked to solve, equals this thing. E to the x sine x minus e to the x cosine x all over 2. Now we did lose our plus c, so usually I just throw a plus c in at the end because I know I lost it somewhere. Right? So that's the process. You do it twice. You add the integral. Now it should work that this integral is a minus, so you add it to both sides. Otherwise you'd have a 0. It should work itself out. All right, pause the video, try this one on your own. Again, it doesn't matter which one you start with, just be consistent. So last time, should I switch it? No, I'm gonna leave it. So last time my trig was u, so this is cosine. Actually, I would not do it this way. Because I want to avoid fractions. You can do it that way. I don't really want fractions though. So I'm going to make this e to the 2x. Because then I'll just have a bunch of times 2 times 2. If you reverse it, you would just have a bunch of 1/2s. The answer will still be correct. It doesn't actually matter. But I want my life to be a little easier. So derivative of e to the 2x is 2e to the 2x. Antiderivative of cosine is sine. All right, so we get e to the 2x sine x minus, I'm going to pull that 2 out front, e to the 2x sine x dx. I dropped my dx again. All right, so then right below this, do it again. My u is e to the 2x. My dv is sine. du, same thing, 2e to the 2x dx. And v is negative cosine. Okay, so e to the 2x sine x minus 2 times u dv, so negative e to the 2x cosine x minus 2e to the 2x. Now I have a negative cosine, so this becomes a positive. Now I need to distribute my negative 2 through. Right? This negative 2 has to be distributed through. So what I'm going to get here is e to the 2x, sine x plus 2e to the 2x, I don't know it, cosine x, minus, now this is a 4 because of this 2 here. I'm going to make that minus 4 e to the 2x cosine x dx. And that all equals the integral e to the 2x cosine x dx. So now I have the same thing on both sides. I have this integral. I'm going to add on both sides plus 4 times the integral plus 4 times the integral. My handwriting is so terrible on those. All right, so we end up with 5, the integral, equals the stuff. I'm going to skip that because I'm being lazy. So my final answer, 2x cosine x dx equals, we end up with e to the 2x sine x plus 2e to the 2x cosine x all over 5, and then I'm going to throw in my plus c at the end. And that is your final answer. All right, this is not all your homework. I started doing it and it was ridiculously long. So I'm cutting this down, so check the classroom for what your actual homework is. Don't do all of that. It is page 554. You're going to be doing a couple of these, but it was way too long. So check the classroom for your actual homework assignment. All right, have a great day, guys.